Hello everyone, welcome to the another video of this week. Today I with my fellow teammates Hanil Mistry and Dev Gundalia. So as you can see, Hanil Mistry is presenting the screen. So can you tell me, Hanil, what is the VRRP?
Yeah, thanks a lot, Isha, for the introduction. So today, uh, as we talked about last week on MLAT, so now it's time that we move to VRRP, and this is basically virtual router redundancy protocol. It is a type of first hop redundancy protocol, and it is a gateway redundancy. So you may have heard what is gateway. You may know like what is the use of gateway, but you never heard of, let's say, gateway redundancy and why it is important. So we'll talk about this in this video. So yeah, let's get started, guys. So before we jump into the uh, content of this presentation, this is the overall introduction for VRRP. So basically we'll understand universal cloud network. Okay, then we'll understand first hop redundancy protocol. It is a protocol also, and a what you can say concept also. So first hop redundancy protocol, there are lots of protocols that falls under this first FHRP. Then we'll introduce VRRP, what is the working, what are the features, and at last we'll see the configuration. So see, first we'll talk about this UCN, so Universal Cloud Network. So basically that is a leaf spine architecture. So wherever you see this kind of leaf spine architecture, that is uh, falls under this category of universal cloud network. So why universal cloud network? So basically this type of structure is used in data centers to introduce redundancy and more of a, you can say, quality of services and all that stuff. So this structure or this architecture, this leaf spine architecture, that is very useful. So I just wanted to introduce UCN architecture. That's why there is just what you can say, there is no relevance with VRIP. And now let's introduce the problem. So just a second. So yeah, let's start the problem statement. So I just said you guys that uh, what is, I just introduced you with the term gateway redundancy, right? So that is this term. So let's say you may have heard the gateway. Gateway is the IP address basically that is allowing access to the other networks. So that IP is configured manually on hosts, right? And let's say we want to get out of this network and we want to connect to the internet. So there will be some IPs configured over here, and on host that are connected to these switches, they may have configured the gateway IP on those devices, right? And let's say per network there should be at least one gateway IP, so that each network can communicate with any network outside of that network, right? So let's say network A, that should have at least one gateway IP, and network B, that should have at least one gateway IP for in order for them, let's say, if they want to communicate with each other. So that is basic requirement and basic understanding of gateway for you. Now if we talk about redundancy, so let's say there is just one IP configured for the network, and let's say we have configured layer 2 structure, right, over here. So all the devices, they might be operating on same subnet, same network, and let's say there is only one IP that is configured for as a gateway. So in that case, what will happen? That IP or that port will be flooded with the all the traffics of this network that is inside this structure architecture. So that introduce some questions, that how we will do the load sharing and what is the redundancy. Let's say if that IP gets failed, then our whole hosts that are under this structure, they can communicate to the internet. So that is the problem, right? And this is the case. Let's say if these two devices have configured the IPs, so these devices that are the hosts that are connected to these switches, they will ask these two questions: what is my gateway and where is my gateway? And these are two separate questions. So what is my gateway? That is the IP address that may have configured on hosts connected to these switches. And where is my IP? Where is my gateway? That is answered by the MAC address, because where I'm just referring, let's say, where, that is a path that you come along, that your packet might goes, and what is, let's say, that is the IP address from where I have to go out of the network. So these two questions you should answer. So this is one will answer IP and this one will answer ARP, or you can say MAC address. So this is the gateway redundancy. So you may have seen this kind of dialog box, right? And these are the
Yeah.
key questions, right? So this we use to configure the IP, and will not deep dive into this, but these are some of the questions. What is my gateway IP? That you will configure over here, IP address. So the answer is, oh, it's at the IP configuration settings. So these are so this is where your what you can say IP address, and this is where your default gateway will reside. Where is my gateway? So that is the MAC address, and don't worry, ARP will take care of it, because where, that is actually, let's say our IP address is over here, or the gateway IP, and our host might be residing on this switch. So where, that answers by ARP. So let's say it's what you can say, take decision based on MAC address, and it will be what you can say suggested to use this link, because that carries the MAC address of the IP configured on this switch. And what if configured IP fails? So that is the problem. So let's say uh, you have configured IP addresses on these two switches, right? And let's say you have configured in the IP settings to use this gateway. But let's say you have configured two IP addresses as gateways. So what if that one IP address gets failed? You need to change it manually to the second IP address, because you can't dynamically change this this default gateway that is configured over here. So this raises two questions. It is feasible, and what is the solution? So if it is not feasible, because obviously if you need to configure default gateway manually, you will say you're asking your users to go and manually change the setting, and user will not like that. So that is not feasible solution. So we need a solution which can reduce, or you can say introduce gateway redundancy over here. So
Uh,
there,
can you go back to last slide?
yeah,
So I had a doubt in like how does configured IP fail?
okay. Let's say you have configured this interface to be IP address. Let's say gateway IP. This interface has been configured as gateway IP, and let's say due to some reasons or some physical links damage, let's say this interface gets failed, or let's say there are some hardware issues uh, that causes this uh, interface to get failed, and let's say our whole packets if they want to access the internet, they will go to this IP address, because the default gateway IP is configured over here, but your packets will not get reply, because this interface has failed due to some hardware malfunctioning, or let's say physical damage to the link. In that case, default what you can say configured default gateway might be failed. Configure IP, I should have wrote over here to be specific. Let's say configured interface gets failed, or you may not be. Let's say there is a situation where you will not be able to contact your gateway. So what is the solution,
Yeah, that makes
right?
sense. But when you configure an IP on the gateway, right?
Yeah.
So all these the in the Windows driver of configuring IP, they would have obviously written a fallback, right? So if they don't get that configure IP value, which is failed, so they would get let's say,
Yeah,
just
they
like
would.
we have a null value or empty array in JavaScript if data is not coming. So similarly, maybe here they have given a fallback IP address something, so it doesn't fail.
No, there is no fallback IP. Actually, when let's say you are trying to contact your gateway IP, you have configured the gateway IP and your packets somehow not getting the replies. In that case, it will just throw you the error which says destination host not reachable. If you have heard this error somewhere, or if you have read this error somewhere, when let's say you are trying to ping some IP, but due to some reason
Yeah,
it gets the reply destination host unreachable.
yeah,
So it knows your system knows that you need to contact your gateway IP, which is configured over here, because the network subnet mask will not match with your network. So that is the reason for what you can say packet to carry the gateway IP, right? And let's say gateway IP is failed due to some the reasons that I have cleared before, and let's say your packet's not getting the reply. In that case, it will throw one error that
yeah,
destination host is not reachable. Or let's say your whole interface got failed. Let's say the interface it's hardware malfunction due to some reasons, so the packet will not be received on this port only. In that case, your machine will throw one error that will say what you can say uh, the timeout error, something like that. There are two things: timeout and destination host not reachable. Let's
yeah,
say physical link is damaged, so your packet will be received on this port, but it cannot be reached. It cannot be go beyond this port because the physical link is damaged. So that time your this interface will reply that destination host is not reachable. But let's say the hardware went down, hardware malfunction is there, so the packet will not be received on the gateway interface itself. In that case, you will receive timeout error,
yeah.
right? So these are the problems that you may or might come across. So
Yep,
what is the solution then, right? So for every problem in networking, we have one solution. So do you have a gateway? That is the question that we might ask when uh, to the switch when we want to communicate outside our network. And let's say one device is there that will say that, oh, I have a lot of them. Let's say one IP gets failed, I have another one. Let's say one that another one gets failed. Oh, don't worry, this switch will have lots of IP addresses. So that is the solution that you want. You might think at the first. Let's say we introduce lots of IPs, lots of gateway IPs, and any if we can and if we ping any one of them, we'll be able to contact one, right? That is the ideal solution that you might think of. But let's just clear about FHRP at first. So FHRP is a protocol and a concept also, and many FHRP exist. So FHRP stands for First Hope Redundancy Protocol, and there are many FHRPs: HSRP, GLBP, and VRRP. So they are namely Hot Standby Router Protocol, Gateway Load Balancing Protocol, and Virtual Router Redundancy Protocol. So we'll talk about VRRP in this video, but just for the information, HSRP is Cisco proprietary protocol and active standby approach, where let's say there are if there are obviously the FHRP is the concept where you will have multiple gateway IPs to introduce redundancy, right? An active standby, that is the approach where one will be active, and when one configured gateway IP gets failed, the standby one will be take place of active. So that is the active standby approach that is HSRP is using. VRRP is using a similar approach as HSRP, but it is suitable with the mixed vendor hardware. So this is Cisco proprietary, and Cisco protocol will not be, or let's say might not be supported by the other vendors. So that's why VRRP is IEEE standardized, and it can if it is able to communicate with, let's say, where there are mixed vendors hardware. So that is the plus point compared to HSRP. And out of all of these two, GLBP, that is Gateway Load Balancing Protocol, that overcomes the limitations of HSRP. So this active standby mode, there is only one active gateway. So it introduced the redundancy, but there is no load sharing because there is only one point for your network to, let's say, enter your traffic and for your traffic to get out of your network. So the bandwidth at that particular point or that particular link, that may be what you can say bottleneck. So for, let's say, overcoming that the limitation, GLBP is there. So what you can say difference between HSRP, VRRP and GLBP is that GLBP uses active redundancy approach rather than active standby. So there are multiple active gateway IPs, and you can contact any one of them, and you will be able to get out of any point, and that will work very perfect. So these are some of the things about FHRP, and now there are some VRRP stuff, but uh, we'll keep it till here, and we'll talk about all of the VRRP in next session. So remember, we have talked about FHRP, what is the problem, why we need VRRP, and what is the UCN structure. So that's it, guys. Do you have any questions?
Yeah. So that's it. And we will continue your topic in next session.
Yep,
Thanks.
yep. Okay, guys. So keep watching our videos, subscribe to our channel, follow the LinkedIn page of the Video Geeks, join our Discord server for latest updates, and yeah, we'll meet in the next video with the VRRP. I will tell you, or we can say teach you, how to configure VRRP in your devices, and we'll go through all of that in the next video.
Uh,
For now,
and also check the description of this video. There is a link to our website where very good stuff is put.
yeah. Also, make sure to check your what you can say Video Geek site. There are lots of resources. We'll include the detailed material of this video content that we are presenting to you, and they are very organized. So yeah, you check out that too. For now, that is it for today's video. We'll meet in the next video. Till then, keep learning and keep exploring.